Okay, good morning, everyone, and welcome to this session. My name is Nair Wenas, and I'll be talking to you today about advanced modeling for natural language understanding using LUIS and Azure Cognitive Services. And since we're talking about LUIS, it might be a good opportunity for us to introduce some of the new features we have in LUIS. I know some of you have actually tried a few of them. I've talked to a few people over the last few days who have actually sort of went into our preview stuff and went through that. So I'll introduce you to that. And also we'll run through some of the best practices of how to do some more sophisticated modeling using LUIS for natural language understanding. So just a show of hands, like how many people sort of have done something with natural language understanding previously? It's a good number. How many have actually used LUIS? How many have emailed me at one point in time? Okay. So there is a growing interest in this space. Conversation is becoming a really big thing, and how to use AI in order to do that. And LUIS is the tool for that. And just in favor for our courtesy to the people who are not aware what LUIS is a cognitive service to do language understanding for developers or people who do not have any AI expertise. So we do all the heavy loading of trying to do that in the back end, and you just use it to extract information. It does use machine learning algorithm and actually is based on something called machine teaching, which for a simple explanation to that is a mix between machine learning and human-computer interaction in order to improve the learning ability and create these models pretty quickly and efficiently. And the intent of natural language understanding is to extract intents and entities or elements within your text that is machine processable, so you can take these and have that into logic, such as in conversational systems. So what's new in LUIS? This Ignite, we're announcing a few updates that are based on feedback we're receiving from our users and interesting stuff to help them improve their ability. So we bucketize them into 3 buckets. So the first bucket is about the core language understanding. And to that, we are improving your ability to do more sophisticated models by increasing the hierarchical decomposition and depth of your structures that you can encode in this, and allowing you to feed intents and entities or models sort of to feed into each other. And that might sound very complicated, but I'll actually run through explaining some of that. And also, we've learned a lot about the feedback we have from our UI, and we're trying to improve it and also sort of give a new experience with these features that we are introducing, and I'll also run you through that. Developers use these tools, and we are very interested to enhance their experience. And to that effect, we are GAing our APIs, our runtime APIs v3, and natively supporting the LU format, file format, in order to help you improve the manner in which you can actually do continuous integration and continuous development. And we're streamlining our key experience along with Azure, which I'll also sort of run you through that. And the final bucket is regarding languages and pre-built models, and we continue to advance those to our customers. And to that, one of the major feedback that Cognitive Services all up has been getting is about our support for languages as these services become more global and they have more access to a variety of languages and cultures. So Cognitive Services has been getting that feedback, and LUIS is not very different from that. And to that, we have started to improve our support for the multiple languages, and I'm really happy to announce in this Ignite that we are supporting a few more languages, including Arabic, Hindi, Gujarati, and Telugu. And these languages allow you to develop in these native languages models for about 2 billion customers and 24 countries specifically for that. And with the global presence of a lot of our customers, that is really important. We also continue to expand on our pre-built models. So we do have 2 types of pre-built models. So pre-built entities, which are recognizers for things like date, time, number. They're very well-formed recognizers, are open sourced by Microsoft, and we integrate them into the model, and we're taking them to these multiple languages so that they're all aligned with English. Very soon, we'll have sort of a full support for all of these languages with the pre-built entities. Another type of pre-built model that we have are pre-built domains, which are small Lewis models to do a function or a skill. So things like to do or a calendar skill. We have developed them. You can insert them into your model, and in turn, you can customize them. So there are specific intents and entities you upload with example utterances, and you can go and change them and plug them into your eventual Lewis model and train them. We have moved them to multiple of our languages, and we'll continue to make sure that they are bar across all the languages, and we continue to grow these set of skills. As a matter of fact, these skills are actually a fundamental part of the custom virtual assistant. The custom virtual assistant is a part of the bot framework. If you're not aware of the bot framework, it's the platform to create conversational AI systems that we also integrate well with, and we're part of that team. So these skills, they accelerate your ability to create end-to-end bots and conversational systems. They integrate Lewis, Q&A maker, speech. They do insights. They allow you sort of to analyze your model. They suggest different architectures to get you up and running from an end-to-end solution, and they're customizable. And there's tooling to actually process and work with these skills. There is a variety of skills addressing things like productivity, different industries, and there's a few other experimental skills that we will sort of working on. There is 2 sessions tomorrow, a theater session and a breakout session that will explain a lot more about that if you're interested, and I would suggest that you actually go to that, including the session sort of tomorrow at 11:45. Darren will be introducing these virtual agents. Okay, so rather than run you through slides and try to say this is new and that's not very interesting, so I thought we'll take this chance in this session to go and design a model. So we are designing a pizza bot. So Microsoft now is in the pizza business. And if in their pizza business, they need a bot. So this bot has to allow you to order a pizza, accessing the full menu, allowing you to customize your pizza. Delivery methods, payment methods has to have some niceties, so it has to have confirmations and sort of greetings and all that nice stuff, and has to be able to handle this from an end-to-end scenario. And in order to do that, you would probably need to access a set of devices, maybe a mobile device, have a web chat. If you're having speech, then you probably have a speech API. You'll probably need some analytics to understand the behavior of your model, and all of these are packaged in the bot framework. And at the core of this, you would need a language model, which we'll work ourselves into. So before I actually jump into the model, let me show you the bot. We've gone ahead and done a bot. And if you're unfamiliar with this interface, this is the emulator. I did get that right? That is 8, sorry. So there we are. So this is the emulator. It allows you to actually sort of play around with your bot once you've created it. So we went ahead and created a bot for Microsoft Pizza, the best pizza in town. And we will see how it responds. So I will order. I would like to order Hawaiian pizza. And just side note, Hawaiian pizza was created by a Canadian, which is like really interesting. I got to learn. He's like close to where I live. So this bot is able to understand that I want to order a Hawaiian pizza. It can understand that I actually want one because I didn't say a quantity. It has put a default size because I have not identified a size. And I have not done any modifications to that. If we go a little further, just to avoid any typos, to make this a bit faster, I have pre-typed these. So I want to order one large pepperoni pizza with extra cheese. So again, it's able to identify that this is a pepperoni pizza. It's able to identify a quantity because I have not said something. The size is now large. It has determined a crust that is default. And then adds a cheese on the whole pizza because I did not define a scope for that. So back to the presentation. And how do you go about and model that? So that specific example that I showed there, and for some reason OK. So we want to create a schema. So basically, when you do a language understanding model, you have to create a schema of intents and entities. So in this specific example of the pizza pot, we need to define a set of entities that include a pizza type, include a size, and a quantity. And you can add other entities sort of that make this more interesting. So kind of a topping, extra is a kind of modifier to that. And you can play around. And these are some of the sample entities that you can create around this, this model. You can use the number, pre-built entity, and date time if you want to deliver or pick up at a certain time. And you would probably map your actions to intents. So I want to order a pizza. I want to modify a pizza. I want to cancel something. I want to add to this. And this is where most people sort of start with this model. The problem with this model is the type of intents that are there is that they expect a very simple world. It will be great if this world is so simple, but when you order pizza, it's actually a bit more complicated. Such models are more helpful when they call in command and control. So if humans are talking to a machine, or they think they're talking to the machine and they're aware of that, so I'm talking to my car, I tell turn up the volume. I usually sort of have one command, very cut out and very easy to actually detect. And these type of models would work. But when talking about pizza, it's a bit more complicated because people add a lot of things. So I want to order a pizza, and I actually want to remove a topping from it. So these, in many cases, a lot of people fall into thinking that this is a multi-intent problem. I have different intents in there because I already designed an order and designed a remove. And I order multiple stuff. Like if you're like me, I just want to offload everything. Like just, OK, this is all my order. I don't want to talk too much, get it everything, and get it done. So you actually need to be able to define when an order starts and when an order ends. And sort of the command and control models will not be very suitable. Intent-driven models, in this case, you probably need a more entity-driven model. And that will also require that you drive more structure and decomposition into that model in order to be able to capture these things. So just before I start sort of digging into how to do that entity, like entities are a very strong and powerful tool within Lewis. You're able to do a variety of them. And in many cases, some people have questions, when should I use different entities? So by default, you should use a simple entity, which is a machine learned entity. So the example here would be the pepperoni pizza, and that should be your default. In some cases, when you have a very small and bounded list, so for example, payment types, delivery, pickup, these are very bounded, or pizza sizes. They're not going to change. Like pizza sizes are not going to change every day, and they're very limited. And you can actually account for the different ways that people can express them. So a list entity would be very helpful for you. It does an exact match. Pre-builts are very good and handy. So if you want to detect a number, so the number 1 there is a number, a pre-built. You don't need to go and learn that again. Sort of, they're very well formed. They're very easy to use. You should definitely plug in pre-built entities. There is a function called roles. So I can order 3 pizzas, and I can order 4 cheese pizza. They're both numbers, 3 and 4, but they have different contexts. So you actually define a role on top of any of these entities in order to use them in specific context. And composite entities bind together a set of entities. So in this example, you can have 3 entities, 1 large pizza, so a quantity, a size, and a pizza type are an entity that defines a composite. But you can also define actionable composites. You can define an action along with that. So remove is actually an action, which people tend to think about it as an intent, but they can think about it more as an entity now. So I can do remove. I can do change. I can bind actions. And in my output JSON object, I know that this is a composite that reflects a certain action that I need to do in my post-Lewis logic, and I'll take action accordingly. So actionable composites are a key element of doing entity-driven models. And the final entity type is regular expressions. I don't have one up here as an example, but product IDs are a very good example of regular expressions of alphanumeric characters that you can actually define and use. Just a tip, if you're doing modeling, I usually tell people to over-detect entities. It's good to have to vet out the wrong ones, then miss on any of them in there. So you over-detect them and then resolve the ones that you actually see as redundant or sort of are more important to keep later on. So this is a more form definition of these entity types. I won't run you through that detail. You can more or less read the documentation. But just to highlight sort of the machine learned simple entity, and there's the non-machine learned entities, the list, pre-boths, and regular expressions. And decomposition and hierarchy and structure come in the form of composite and roles in the current implementation of Lewis. You can build on top of these basic elements any form of hierarchy that goes to 2 levels. So you can have an entity and a composite. So we only have 2 levels of structure that we have, and we can use actionable composites. Actually, a friend of mine works in Microsoft. I've worked with them in designing some of the models. They coined that into a nice phrase. It's called intentities, which is a really fun name for it. I really like it. So you can use intentities, which are actionable composites, in order to capture the remove and identify different elements. But now, how do I actually do the multi-layer parse? So I know that an order starts and an order ends. So the entities here would include the remove item on the side there and the replace item. And they've taken out from the intents into the entity bucket. And to do the second layer parse, you can actually cascade multiple Lewis models. So you first understand your first layer of entities, your composites. Then you pass it over using the API v3, the runtime API v3, which allows you to predetermine a set of entities as you input a query. And you take it to the next model in order to do the level parse. And I've designed models that actually use this structure in a service. But that comes with a cost. There's a latency cost because you're doing multiple layer models. There's a cost of maintaining multiple models and training across it. So there is a bit of a cost associated with doing this model while it actually works. But that cost is something that we have addressed in the updates that we're doing. And rather than have a bottom-up, so entities, composites, and you go up, we do a top-down decomposition. We've allowed the depth of hierarchy to go up from 2 to 5. And you can have models that sort of span that. So you would do the order, a full pizza, and go into the finer details of that entity structure as you go down into individual toppings and modifiers. So this was what you would need in Lewis previously, and now you can actually do a better decomposition of your model. The top-down decomposition also is more natural. It allows you to sort of structure things better as you go from top to bottom. Also, when you're doing your labeling experience and you're doing a Lewis model, and then suddenly you come up with a new division in your entities, in the bottom up, you will have to go and redo everything else because you have that structure and there's some dependency, while here you're doing a child at the end, so you can actually carry on your labeling. The rest has not been changed, and you can continue. So suddenly I define that I can have mushrooms on half of my pizza, so I do have a scope, a notion of a scope. So all I do is just add it under the toppings. Once I see that there's a half, I go through the labeling process and I continue because it has not existed previously. So it makes it more efficient and much easier to build. And it allows you to build more sophisticated solutions with significantly less effort. So to that, let me go back to my bot. Hopefully I got that straight, okay. And let's try a more complicated, before I actually look at the model itself, let me try a more complicated model. So I want to order four cheese pizzas with extra cheese and a chicken pizza without chicken, which doesn't make much sense, but yeah. And with extra mushrooms on half and a side of bread. And that's like a very long order. Humans can actually be challenged to keep track of it. But if you look here, sort of, you can see that I've defined quantity 4 and defined a 4-cheese pizza, and I'm able to differentiate between both of them. I haven't set a crust type, or a size. I've added extra cheese on the whole pizza. And on the chicken pizza, I've removed the chicken from the whole pizza and added on half of it mushrooms and half or side order of bread. So I'm able to parse this very complicated utterance into these very fine elements, and I can go and process them. And actually, sort of, the emulator is nice because it allows you to see what you're doing and trace stuff sort of in the side here. You can actually trace the messages. And adaptive cards are pretty cool. It would have been a nice experience if you can actually customize the image there to the PZR ordering, but that might be a contribution from one of you guys. Okay, so to that we've also sort of improved our user interface to address those and also to address some of the issues that people had with the labeling experience. So our current UI supports this top-down decomposition. It has improved the ability to label entities, including the ability to label overlapping entities, which Lewis was able to do, but the UI was limiting your ability to do it there. And you can actually label large quantity of data pretty quickly and streamlined, so it's a more robust and more useful UI than the previous one. When, like, even myself, when I was labeling in the old UI, I would go through a process and then shift to more of the LU file format because it was pretty handy. This one makes it significantly more easier and allows you to do that and also visualize this labeling schema that you're doing. And the predictions were also something that sort of overlapped in the previous UI that were causing some issues. So this is the UI. You're more than welcome to go to preview.lewis.ai to try it out. And if you're unfamiliar with the Lewis UI, on the left side there is the assets, so your intents, your entities. You've defined descriptors, or you have patterns. You review utterances. This is more of the command. The dashboard and the build management sort of for your model, training and testing and publishing. They're sort of more or less the same that was in the previous UI. I'll run you through the labeling. So this is actually the model. So that very complicated model required about just under 100 utterances in order to do all of that interesting stuff. So I can do multi-layer parse, I can identify different types of pizzas, all of that with that limited number of utterances they can do. So this is the new labeling experience. You can look at in the entity palette for the structure that you have. So I have an order, which is the top layer parse, and as I go down, I have a full pizza with type. I will add a new utterance. I've actually put a untrained version of the model into my Lewis in order to go through the labeling experience. So I will just go and add that model, that utterance, okay. Conflict, so let me reload, maybe it's been open for a while. Yes, I was signed out. Very interesting, am I connected to the right Wi-Fi? Yes, I am. Great, okay, cool. Should show me some labels. It's loading predictions and labels. Wi-Fi is pretty slow. Sorry about that. Okay. Go to this. Is this any better? Okay. Versions, so I will clone this one into 1.0. So we are currently releasing our Microsoft Pizza Bot. Okay, so I go build that, go my intents. Again, retrain your application version, okay. Okay, so I'll have to do that in this one. For some reason, it's acting a bit weird, okay. So this is an utterance that I've added to my model. As you look here, sort of, there are predictions. Previously, your predictions and your labeling were confused with each other. So predictions now are much clearer. This is a trained model, so it comes with a full prediction, but let me actually go and label this. So I would do this as a full order. And then I would do this as a full pizza. And then start to add parts of the full pizza. So this is a 4-cheese pizza. That's the pizza type. There. And this is a quantity. And this is a topping. With modifiers, this is the modifier that I have is with extra. Actually, because these are predictions, I can confirm the prediction, and these are just the topping. You can confirm the whole prediction by that, so it just transforms that into the labels that you had. And if there's confusion with the model, so for example, this is a prediction that is wrong compared to your labeling, so it's pretty obvious there, and you should go and correct your model. The labeling experience is much slicker, it's much faster. You can define a set of entities here, and for every entity, you can inspect it. You can see the descriptors that are associated with it. You can identify roles to it, and you can use it in the context of your model and how you're doing the schema. This UI is much faster, much easier to use. It's much more handy compared to the previous UI. You can actually sort of go and use it, give us feedback. You can go to preview.lewis.ai. We'd love to hear about that in order to ways to improve that UI, and you can play around with it. The other aspect is adding models of features. So in many cases, when you're doing a model, Lewis previously has intents and entities as separate extractors and classifiers. You can't really feed one to the other, but sometimes if I've detected an order, then I should be making an order kind of thing. So if you get an entity, you want to feed it as an input when you're doing the learning to an intent, and vice versa. If you have a certain intent, it can actually help you detect a certain entity in a certain light. And to that, you were able to do it previously externally, so you detect one and then cascade multiple models, which again, sort of adds a layer of complexity that is unwelcomed when you're developing that. So to that, we have allowed you to actually add models one to the others as descriptors, including the phrase lists, which were previously there, but they're added also as descriptors. And it is just as simple as coming here to your model and say, okay, when I want to detect an entity, so if I detect an order, this is a descriptor. This is an addition of an entity to this learning. So when you're learning, you would go and add it. If an order entity is there, then that's a positive signal. If it consistently correlates with that entity, then once you detect it, it actually just fires that intent. And I'll just go about and do the training. The training has become much faster. The notification has been improved. It was a little annoying to say, sort of, to be honest, previously. So this is sort of a much better worked UI in the usage for Lewis, and makes sort of using that portal to do the labeling, especially that you don't need a lot of utterances or a lot of labeling in order to develop such NLU models. Just to sort of better explain sort of how this affects, if you have no data at all, sort of you're probably going to go do rule-based to do your bot. If you have abundant amount of label data, then sort of other more advanced machine learning models might be handy, like deep neural nets, which are sort of the state of the art. But when you're developing, you don't have so many labeled data. They're very costly. Getting that utterances labeled is very hard. So with a small set of utterances, this tool is definitely the tool that you should use to do these kind of models. And in turn, sort of, if you're going to label 100 utterances to do such a complicated scenario, you can sort of do it in the UI. It's very efficient and effective. Also, sort of, we're currently working on allowing you to have more control on your language model. And that is by allowing you to define your own language elements. Currently, Lewis comes with a pre-canned language model for English, French, Italian, and so on and so forth. It makes the learning a little slower with that bigger language model, because it spans a variety of applications or domains. If you have a specific domain and you have a specific lingo that is associated with that domain, if you can actually provide it to Lewis, then the learning would be much faster and much more directed. And we're working towards enabling you as a developer to define them and add them to the model. You can sort of do the cold start model using the language model, but you can always take more control of that moving forward. To put that all together sort of into an architecture, so this would be an example of the architecture. You would connect to multiple channels. If you're coming in from speech and text, that will be the type of input that you have. You'll put it through the bot service, the app insights, reporting, Power BI with appropriate security. And you'd plug in sort of your language model. You can also add Q&A maker if someone wants to order or understand what comes in the crust, if it's gluten-free or asking a question. And you can have your speech API. You would have a text and a speech utterance in that case that would train both of the models. They will have to sort of connect to each other, so every speech and the text. We also do text priming, it's a speech priming. So it'll allow you sort of to take the language model to improve your speech recognition. And you have your menu data that you run through in order to provide for the language understanding to import some of these important information into there. You can also use this in a non-bot scenario, so it's not necessarily also associated with a bot. You can do this in a point-of-sale situation where you can add to a cart or remove to a cart, and that would sort of remove the requirements to have through channels, and you work in the order processing there. The other aspect that we're introducing is the ability to enhance the developer experience. So to that, we have G8, our runtime APIs v3. They allow you to have external entity definitions and dynamic lists, which allow you to define entities that you are clear and you know ahead of time, rather than have Lewis do them. So example I gave sort of when I was demoing this in preview was, if an application is for a soccer team and you know this is my personal favoring, I'll not be saying their name, I'll be saying when are they playing the Buckeyes, when are the Buckeyes playing Michigan? I won't go say the Buckeyes, when are they playing Michigan? And the application would know from my preference that they is the Buckeyes. And you can pass that over to a Lewis model, because trying to generalize for everyone, that is really hard. So you can pass on external entities, you can personalize your list in real time. So if I have my personal playlist, you can add that and learn or process your model against my specific playlist to do that. You can access different versions directly through URL. So previously you can publish to a production and staging model. Now you can publish multiple versions there, so you can actually handle better sort of streamlining your development cycles. And the JSON output is much more formed for you to be able to consume later on. We're also allowing you to import and export .lu file formats natively to Lewis, and their markup inline, more human-readable versions of the utterances there. So you can go and label these entities as you see there, sort of in inline markup. If you're fond of markup, this was really a good tool, and sort of I personally used it extensively prior to the new UI in order to design more complicated models. So now you can upload and export, import and export .lu files natively in Lewis. It improves your continuous integration and continuous development cycles. We've also integrated Lewis better with Azure Resources. So if you have a Lewis model, you'll probably see a pop-up saying that you should migrate your keys. We are accessing your models through Azure Resources. Eventually, sort of, we work for productivity and enterprise, and you need more control on your models. So the migration will allow you, it's a one-way migration to access Azure Resources, so the model will be associated with that subscription, and will allow you better control on your application. Authentication using A2D is currently in private preview. We are working along with cognitive services, to do role-based access control and VNet support, and that is upcoming in the next few months. So just to outline sort of the roadmap moving forward with Lewis. So we're growing the size of the document. So rather than utterances, 500 characters to documents. So Lewis will manage document understanding. We are improving the core language understanding for that by doing advanced sampling in unlabeled utterances, especially when you go to the document space. You probably have a set of emails or a set of documents you want to work on, so you want to actually sample not only in the active learning part, like in Lewis, but also in the authoring part. So we're adding more advanced sampling models to that. We're also doing feature suggestion that would look at the utterances or the documents we're providing and extract interesting features that you can actually use in your modeling instead of the generic language model that we have. We're also working to a feature repo, so sort of you'll have a repository of features that you can actually pull through and just add to your model automatically, just like the pre-builts that we have. We will be working on the role-based access control and VNet support and enhancing the continuous integration and continuous developer for the developer experience. Analytics dashboard, if you've used it, it focuses on intents. We will be working to make it more into entities and being more of a platform for batch testing and looking at your model. And Lewis Containers has been sort of in public preview for a while. We will be having a GA. It made sense to sort of align with cognitive services because Lewis doesn't live in its own world. In most cases, it would integrate with speech and other services, and they all need to be containerized for you to actually make use of that. So we're following with the rest of cognitive services in the release of Lewis Containers. And we continue to support more languages and pre-built models, and we'll expand on them moving forward. These are some of the links. The release notes are at the Lewis Ignite 2019. There's an introduction to the service there. The code for the bot that I've shown is on GitHub. You can get that, and you're definitely more than welcome to join our community and contribute to this. There are a few other sessions happening. There's in this Ignite, you can refer to them. There's 2 happening tomorrow about the virtual assistant. There is a breakout session by Darren, 11:45, and a theater session by Dwayne just ahead of that. And they'll be talking about the virtual assistant. They're very sort of useful to accelerate your use if you have a bot scenario. We love to have you contribute sort of to how we shape conversational AI and machine learning, machine teaching. And to that, if you join our community, you'll get sort of news about what's new. We'll access sort of that a bit early, contribute with your feedback to improving our services. So please join that group and contribute to that. You can evaluate this session. Please do on the application. And you can access this later on sort of on the tech community, and I'll be more than happy to answer any questions that you might have. Which slide? That one. That I can do. That was an easy question. I was expecting harder ones. Is there any questions? I'll be happy to entertain. I either did a really good job or a really bad one with no questions. It's always really odd when you get that silence on a call. Okay. It's very soon, sort of, we're working on sort of to align with cognitive services. It's currently sort of in the last phases. I would say build, but probably way ahead of that, but just to be on the safe side, so no one quotes me on the wrong thing. But yeah, it's currently in private preview, so you can actually, so. Sorry? Is the container running an app server? Yeah, so Docker containers, you can. So you can run it anywhere? Yeah. No, it's a connected container. You can run it anywhere, but it has to be connected. It has to be connected how? Connected for billing. So the totally offline sort of container is still something that is working. I don't know, actually. I'll have to get back to you. It's currently in Azure. And you need sort of, if you have sort of, especially on the shared service, you can have on your model, you can have a VNet. It's not only for the container, but for the container, if you have your own stuff, then you manage everything on your own, and you can do whatever you want. You can sort of whitelist any IPs that you want. In the container, you won't worry about that pretty much. Yes. Everything is in the API, training everything sort of. The labeling is obviously better in the portal, but you can label things sort of the LU and just upload it and do the training. So. Okay. If there's no more questions, then thank you. Appreciate attending the session.